So my screen, could you make my screen visible? Yeah, yeah, perfect. All right. So hello everyone. Hi, I'm Osman, and today we're gonna continue off our lecture from where we left. Right? We were doing we're doing geometry in the last class. Right? We've completed the properties and shapes of the 2D and 2D figures. Right? We've completed how to properties. Uh, Properties of shapes for 2D figures. We've done that. Now we are moving towards another topic which is similar to this one. However, it's a little bit different in terms that we're not going to talk about 2D figures anymore. We're just going to talk about 3D figures now, right? So it becomes increasingly easier for us to identify 3D figures and to work with 3D figures. Now, as you've seen in the past, that with 2D figures we just had two things to find out, right? So we had about area to find out, right? We needed to find out area when with respect to 2D figures, and we needed to find out parameters with respect to 2D figures. Now our main focus would be 3D figures, right? Now, I don't think that we got enough time in the last class to practice for 2D figures, right? So, yeah, so today we're gonna be starting off with a little bit of practice, right? And we're gonna cover off a little bit of what we've studied in the past as well, right? So, yeah, that's about it. Yeah. So let's look at this type of questions. So this is one of the type of questions that we get in the exams, right? So yeah, this is for the shapes, 2D shapes, right? This is for 2D and 3D shapes. This has nothing to do with. This is just for the properties of 2D shapes, right? So this is a question. It says that the area of the parallelogram is three times the area of the triangle, right? So whatever is the area of triangle, the area of the parallelogram would be thrice of that, right? Now we have to show that the perpendicular height of the parallelogram is 4 centimeter, right? So how are we going to do this? Right, first we need to find out the area of this triangle. So we can apply the direct formula to the area of triangle, right? Which was what? Which was half base into height, right? So what's the base over here? For the triangle, the base is 6, right? So half into 6 into what's the height is 8, right? So we could sort it out. It would be 1 2 times 1 is 2, 2 times 4 is 8, right? Now 4 times 6 is 24, so that is the area of the triangle. Now with area of the parallelogram, right? So area of parallelogram, what's the formula? The formula would be half sum of both sides, sum of parallel sides. Oh, sorry, area of parallelogram. Yeah. Area of parallelogram would be length times or base times height, right? So base times height. It's base times height, right? So what is it gonna be? We know the area of the parallelogram. Although we can find out the area of the parallelogram. How? It says that the area of the parallelogram is thrice the area of the triangle. So area of the triangle is, let's say, 24, right? So for area of the parallelogram, we'll have to multiply it with 3, right? So 3 times the area of this triangle. So 24 times 3 equals to, what's the base? Base is 18, right? So now we need to find out the height, right? So we take the 18 to the denominator, right? So it becomes 3 times 24 divided by 18, right? So 6 threes are 18, 6 fours are 18, 3 ones are 3, 3 ones are 3, right? So we're left with 4. So h equals to h, which is the height, is equals to 4 centimeter. I hope that this question is clear to you. So this is a majority of the questions are like this, right? So it's not that difficult. However, it does require a little bit of concentration and a little bit of understanding, right? So now what you need to find out. So this is another type of question which usually I believe that the students find a lot difficult, right? So let's look at it. Now the question says that the pattern is made from two similar trapeziums, right? Show the shaded area of show that the shaded area is of 294, right? So it's pretty simple, it's pretty easy, it's not that difficult to understand, right? So it involves a little bit of concept from similar figures as well. Now either we can do this because we've not studied similar figures as of yet, so I think we should work out to another example because we've not done similar figures as of yet, right? So let's just leave this example. Yeah, let's look at this one, right? So this is a figure given to us. Now we need to find the area of the shape. Okay, so this shape is, we haven't studied, but in particular we haven't studied the shape, right? So we need to make a shape out of this so that we can find out a shape that we know of, right? So what can I do if I draw a line over here from my own will, right? So this becomes a rectangle, right? Now this side, I know this side is 2, similarly this side would be 2 as well, right? Now what would be the length of this side? Okay, so this is an important decision. Now this side is 10. Okay, so if I minus 2 from it, I'm gonna get what? 8. So this length is 8. So now we need to find the area of the first one, which would be area of first rectangle, right? It would be what? 2 times 8, right? So the answer would be 16, right? Now we are left with 2 times 8 again, right? So we can find out the second triangle as well, which would be 2 times 8 and 16. So now area of the total figure, area of total would be what? It would be 16 plus 16, which makes up 22, right? So that's the area of the total figure. I hope this is pretty simple. This has nothing to do with like a lot of difficulties, right? So this was pretty simple. Um, Perfect. So is there any question, queries, anything? Feel free to ask me if you guys do not understand it or anything. Is everything clear up till now? Perfect, perfect. If everything's clear, then that's perfect. Okay. So now let's do this question for a while. Okay. So take a minute, okay, and go through this question if you see if you can solve it. So which shape is it? So this is a trapezium, right? This is a trapezium that we studied. Now let me just revise of the formula for the area of trapezium. It's area for this one, right? For trapezium, it's what, 1 over 2 sum of of parallel sides, right, multiplied by height, right? So we do not currently have this length, right? And now you need to figure out what this length is and how are we going to find out its value. Okay, so I hope that this is very clear to all of you. Now give it a try, give it like a minute or two. If you guys aren't able to do it, I'll do it with you, so don't worry about it. Just give it a try, okay? So did anyone come up with a way? Yeah, so let's do it together now. So it's half sum of parallel sides. So you need to figure out which two sides are parallel in this, right? So it would always be the straight lines, right? So these are the two lines that are never going to meet with each other and hence are parallel. So you're going to add them both. So it's going to be what, 2.8 times, oh sorry, it's sum. So 2.8 plus 2.1, right? And now multiplied by the height. So we do not have the height, so this length, right, is basically nothing but a height of this figure. Why? Because this length is forming 90 degree with the base, so that's the condition for a height, right? So you might name it anything that you want to, but it is just pretty much the exact same as the height of this figure, right? So now we have an area. We are given the value of an area which was 39.2, right? So what you guys need to do, let's move 2 to the upper side. So it's 39.2 times 2, right? Now 2.8 plus 2.1, right? So the answer is 4.9, right? So 4.9 times height, right? So 39.2 times 2 is 78.4, right? So 78.4 divided by 4.9. Now you're going to be left with the height. So the length of the height would be what? Length of the height would be 16, right? So you now have the value of 16 for the height. I hope this everyone understood this, right? Do you guys have any issues in understanding? Is there anything that you did not understand? Are you guys sure that you understand this? Okay, so now let's move on to another question, right? So this question is about sectors, right? Sectors was one of the things that we studied towards the end of the class on Friday, right? So yeah, let's do this. Now this is a sector. It has an angle of 120, right? It has this length of radius which we need to find out. It's 8. It's 8, right? We are given the value of the area. So right, can anyone tell me the formula for a sector? How do we calculate the area of a sector? What's the formula? Do you guys remember what's the formula for the area of a sector? Okay, so the formula is theta divided by 360. Theta divided by 360 times pi r square. Okay, so now we are missing the value of r, but we have the rest of it. So the area is 8, right? And now the theta is 120 divided by 360, right? And then you have pi over here, and you need to find out the value of r, right? So yeah, now let's solve it. Okay, so say 60 goes to the other side, it's going to be 8 times 360 upon, now the numerator 120, and pi moved to the denominator on the other side, so it would be 120 times pi, and it would have r square over here, right? So the answer would be r square equals to, now it's 8 times 360, right? So 8 times 360 divided by 120, then divided by pi, right? So the value we've gained is 7.64. Okay, so 7.64, but that's the value of r square, right? We need to find the value of r. So what do? We take roots on both the sides, right? Taking root on square gives us r, right? And now taking square root on this side would give us 2.8, right? So the value that we got is 2.8. I hope everything's clear to all of you. Is there anything in this question that you did not understand? Feel free to ask me right now. Okay, so this is one of the most common type of questions that we get in our GCSE exams. Okay, so this is one of the most common use case of GCSE exams, because it's not only related to this chapter, but it also includes another chapter of um, equations. Okay, so these formulas aren't really listed online. They are, maybe you can find them online as well. But in the last class, I did write them all, and ask you guys to, note them down, because they're gonna be handful when you're gonna do this. Okay, so now let's see this. Now this is a square, right? They've asked us that by setting up and solving an equation, show that the perimeter of the square is numerically equal to the area of the square, right? So I don't know why, but if this is a square, then the lengths of both of these should be exactly the same, right? So let's do this. Maybe they've mentioned it a square, but it's actually not a square, it's actually a rectangle. So let's do it. So let's see if we do it correctly. So these two lengths are equal. Let's do these two lengths are equal. So use the formula. Perimeter would be what? 2 times opposite length, so 2 times breadth plus 2 times length, right? So 2 times 4 minus 4x, sorry, 4x minus 10, right, plus 2 times 11 minus 2x. Okay, so let's solve it. So 2 times 4 is 8x, right? And now 2 times 10 is negative 20, plus 2 times 11 is 22, plus 2 times 4, 2 is negative 4. Right, so the final answer I get is 4x, because 8x minus 4x, and now 22 plus minus 20, so we get plus 2, right? Let's solve it for the area as well. So it's going to be length times breadth, right? Yeah, so it's going to be 4x minus 10x times 11x, 11 minus 22, 11 minus 2x. Okay, so if we multiply 4x with 11, it's going to be 44x, right? Now 4 multiplied by 2 is 8, so it's going to be negative 8x square. Now it's going to be negative 110, and this is going to be negative 20, right? So let's solve it. We're going to be left with 44 negative 8x squared. So ideally we're not getting the equal values. Okay, so we're not getting the values equal, so we'll write down that because it's a square and we do not have the same values, hence we're gonna be we do not have the same value, right? So now let's move on to another question, right? Let's do this part of the question first. So yeah, let's do this part. So it's similar to what we've done already, right? So can any one of you just quickly calculate the area and let me know what the area would be? Okay, so this is a very similar question to what we just did, right? So faster finger guys, come on, quickly solve this question on your own, because no matter how many times I teach you that, but if you are not going to solve it yourself, the chances are that you might not learn a lot. Okay, so let's solve it. All right, so let's say that we need to divide the shape into two parts, right? So this one becomes a rectangle, right? So now if this is a rectangle, its dimensions are 9 and 2. So let's find this area out. So area equals to 9 times 2, which is 18. So this area is 18. Now what about this area? We do not know the length of this side. So how do we find out the length of this side? This whole side is 8, but this side is 2. So 8 minus 2, we get 6. So this is 6. Now area becomes equals to 4 times 6, right? So the answer would be 24. Now to find out the area of the whole figure, we're gonna add them both. So area equals to 24 plus 18. Yeah, so it becomes 18 plus 24, it becomes what? 42. So that is the area of the whole shape. I hope you guys get it. I was getting some answers of 24, and yeah, I got an answer of 42 as well. Perfect. Good job, guys. Now let's move on to our topic of today, right? So this was pretty much past repairs and other workings, right? So now let's move on to the topic that we had in mind for this class, right? It's gonna be 3D figures now. Okay, so with respect to 3D figures, with respect to 3D figures, the examiners can only ask us two things. Okay, they can ask us the volume, okay, or they can ask us the total surface area. Okay, so these are just the two things that an examiner can ask us, right? Now, when we're solving these questions, we need to keep in mind that we're solving them in order to get the right amount of values. So this is volume and this is total surface area. So what's the difference between volume and a total surface area? Can anyone reply me? Can anyone tell me what's the difference between a volume or a total surface area? Right, so total surface area is the area that is occupied by the shape in its surrounding, right? But the volume of the shape means how much can it carry, how much can it contain. So that's the volume, right? So let's begin with much similar and much seen shapes. Okay, so now we have a square right here. Okay, so let's imagine that this square. Okay, so these are the two squares, right? Now if we, yeah. Now if I connect these lines like this, so two squares make up a shape called cube. So this shape is called a cube. What's the speciality of a cube? Let's say that this is a length, right, of some, let's say that it's 4 centimeter long, right? And now because it's a cube, the all the shapes are going to be the same, right? All the sides are going to be exactly the same. So this is what the speciality of cube is. Okay, now you can have same dimensions on both length as well as breadth as well as height of the shape. Okay, so do you guys get it? So we can write the volume of this shape as length times length times length. All right, so this becomes what? This becomes length cube. Now talking about total surface area, right? So talking about total surface area, it's going to be pretty simple. So we're going to have, how many faces do we have when it comes to a cube, right? So we have around six shapes. Okay, six faces, one in the front, similarly one in the back, right? Now one on the side, this side, and now similarly one on this side as well, and now one on the bottom and one on top. So we're gonna have to find the individual area of each face to make up a total surface area. However, because we have length as dimension of all the sides, so it's pretty simple. Now for the face, it's gonna be length square, right? Because it's gonna be this square shaped face, right? Because it's the same face all around the cube, it's gonna be six times, because there are six faces, so it's gonna be 6L square. I hope that this is clear, right? If you guys did not understand this, it's gonna become much more clearer when we do rectangle. So let's do a rectangle one. Okay, so if I have a rectangle like this, all right, so this is a rectangle. So a rectangular 3D shape is called a cuboid. Okay, I'm telling you these names because it's important to know, because in exams sometimes they don't even mention you the shape, right? They just write down the name of the shape, which is cuboid. Okay, so this shape is called a cuboid. Now let's say that this is the length. Okay, so this is the height, and now this is the breadth of the rectangle. Now, if it comes to the volume, what are we going to do about the volume? So the basic formula, the basic fundamental thing of a volume is to find out the base area, okay, to find out the base area of a figure and multiply it with the height. Okay, so now the base area of a figure would be what? This times this is the base rectangle, right? So it would be what? Length times breadth times height. Okay, so this becomes the formula for the volume, right? But when it comes to total surface area, what are we going to do? See, this surface right here at the bottom, at the base, is exactly the same as the top one, right? So what's the area of this shape? This was the how are we going to find out the area of this rectangle? So we're going to find out by length times breadth, right? But because it's the same as the top one, so we're going to multiply it with 2, right? Now we do this side, so let's say this side. Okay, so this side has a dimension of L over here, oh sorry, H over here. So this is height times breadth, right? Height times breadth, right? But because it's two of these at the back as well, so it's going to be what? It's going to be height times breadth times 2, right? And now when it comes to this front of this shape, okay, so the front of this shape, it's exactly identical to the base of the to the back of the shape as well, right? The front of the shape is L and H, right? So L times H times 2. So this is going to be the total surface area for a cuboid. I hope that this is clear. Are you guys clear with this? Do you guys have any issues, any problems in understanding this? Or is this all very clear to you? Now, so you've learned the basic fundament of finding out the volume, right? So the volume, to in order to find out the volume, what we do is we take out the base area for the figure and then multiply it with the height. So that remains constant with every figure that we're gonna do, except for the fact that there might be some ratios because it's not the whole figure sometimes, right? Yeah. Now let's move on to our favorite portions. It's gonna be pyramids now, right? Let's talk about pyramids. Okay, so how many different types of pyramid do you know? How many different types of pyramid do you know? So one of the major types of pyramid that we know is a square base pyramid, right? It's all about the bases. Okay, so a square base pyramid. So what's a square base pyramid? This one. Okay, so it has a base of a square, and now if I draw a top view of it, it's gonna look something like this, right? But if I draw a vertical way or like this, it's going to look something like this, right? So this is a square base pyramid. The pyramid which has a base of a square, it's called a square base pyramid. Then we can have many different types of pyramid. We can have a rectangular based pyramid as well, right? So what's a rectangular based pyramid? So rectangular based pyramid is something like this. It has a base of a rectangle and then a four triangles on the top of it. Okay, now we can even have a circle based pyramid. So what's a circle based pyramid? Do you guys know what's a circle based pyramid called? Now what's a circle based pyramid called? It's called a cone. Okay, so you guys might have seen a cone, a picture of a cone. I'm gonna show it to you right now here as well, right? So if you see a cone, it's nothing but a circular base pyramid. You see this shape? So you see this shape right here is a, it's nothing but a circular based pyramid, right? So I hope this is clear to all of you, right? Perfect. So somebody did answer it correctly, like what a circle based pyramid is, right? So now what are we going to do about this? How are we going to find out the volume of pyramid and the total surface area and everything like that? Okay, so let's begin, right? So this is a pyramids is not that complex. I don't know why, but I've learned in the past few years that students find it very difficult. But let's see. Okay, so I hope that it will be clear to you, all of you now. So in order to find out the volume of a pyramid, the simple formula is we divide 1 by 3 and then apply the same rule. What's the rule? We find out the formula, we find out the base area. Okay, so we find out the base area and then we multiply it with the height, right? So this is how you're gonna find out the volume of this pyramid, right? Now if we talk about a rectangular base, square base pyramid first, okay, so let's say that this is a square base pyramid, or let me just get a picture from the internet. Yeah, now let's see, this is a square base pyramid, right? So this is a base of the square, this is the base of the square, right? And now what's the height of the square? So from the top till the bottom of the base, it's 90 degrees, it forms 90-degree with the base. So this is the height of the square base pyramid, right? So I hope that you guys get it and understand it now. Okay, so this is the height of the pyramid, right? Now if we have to find out, let's look at this example. Okay, so if we have to find out the volume of this shape, so what exactly do we need to find? We need to find out the, because it's a square base pyramid, right? So if this length is 6 centimeters, then this length is automatically 6 centimeters as well, right? 6 feet as well. Now what was the formula? Volume equals to 1 over 3 times base area, right, times height. So according to this, the base area becomes what? What's the area for a square? The area for a square is 6 times 6, right? 6 times 6. Now it's 1 over 3. What's the height of the shape? Okay, so what's the height of this pyramid? Right, so the height is unknown to us. This is the height, okay, but we know the slant height of the shape. Okay, so we know the slant height of the shape, and we also know this little length right here. Okay, so we can definitely find out the height of the shape. So how are we going to find out the height of the shape? Okay, so now we've learned about the Pythagoras theorem, right? We've learned about the Pythagoras theorem. So what's the Pythagoras theorem? If I have any 90 degree, I have this, I have to find this, right? So hypotenuse square minus base square equals to perpendicular square, right? So 5 square minus 3 square equals to x square, right? So it's going to be 16 equals to x square and x equals to 4. So now I have the height of 4. Okay, So now let's put it in, okay, and find out the answer. So 1 over 3 times 6 square is 36, right? Times 4. Okay, so the answer becomes what? 3 ones are 3, 3 twelves are 36, right? That's 12 times 4 is 48. So this is the volume for this shape. I hope all of you understand this. Is there any one of you who doesn't understand this? Kindly let me know. So I hope that this is clear, right? Now let's move on. So this thing is similar for a rectangular base pyramid as well, right? Now let's suppose that I were to give you the same question, okay, but change the dimensions a little bit. Okay, so now this time it isn't a square base pyramid, it's a rectangular base pyramid. So what would change, right? So what would change? This length would change, right? So if I say that this length is no longer 6 feet, this length is approximately 8 feet. Okay, so now this becomes a rectangular base pyramid automatically, right? Now what do we do with this? What do? We simply apply the same concept. Okay, so we simply apply the same formula that we've learned, which is volume equals to 1 over 3 times base area times height, right? So what's the base area? The only thing that differs right now is the base area. Okay, so it would be what? 6 times the area of a rectangle, right? So one length is 6, one length is 8. So how do we find out the base area of a rectangle? We multiply them both. So 6 times 8 is what? 6 times 8 is what? Is what? um yeah, 48, right? So we're gonna use that value, and because we've calculated the height in the previous question, so it's gonna remain the same. So the height would be 4, right? So the only thing that differs is the base area. So it's gonna be what? 6 times 48, and then multiplied with the height, right? Now what is it gonna be? The final answer is gonna be, so 48 times 4 times 4 divided by 3, so it becomes 64. So your volume for this surface, this question is going to be 4, right? So I hope that this is clear to all of you. Is there any question, anything that you do not understand? Is Please let me know. Perfect, perfect, amazing. All right, so all of you are getting the right concept, right? So now let's look at this question now. Okay, so now we're gonna move on to our concept of cube. Okay, so once I'm done with the concepts of volume, then I'm gonna move on to the concept of uh, can you show how got H? Okay, so that. Let's see this. Okay, so this was our triangle inside the pyramid. Okay, so we knew the slant height, right? We knew the slant height, which was 5, right? We knew the base and the half of the base, which was 3. Okay, so this length is 6, then the half of this length would be 3, right? And because it's a height, right, so it drew straight down. So now here's the working that I've done for it, right? So we can use the Pythagoras theorem to find out the value of the unknown. Okay, we can use the Pythagoras theorem to find out the value of the unknown, okay, which is x, right? So you can use that to find out the value. which is 4. I hope that this is clear now. Perfect. So now let's come to cones now. Okay, so essentially what cones are, I just told you guys that cones are essentially the exact same things as a pyramid with a circular base, right? So the formula is 1 over 3 base area times height, right? So that's the base formula. Okay, now what's going to be the base area for cone, right? So its base is a circle, nothing else but a circle, right? So it's going to be 1 over 3 times, what's the area of a circle? We've learned this in the past, that the area for a circle is pi r square, right? And now what's the area for the height? Oh, what's the value of the height? So we'll do that in the next step. Okay, so you get it. So this is the formula for the volume of a cone, right? Now we just need to put in the values of r and h, and we're gonna get our volume. Okay, so right, what's the radius when it comes to this face, this surface, right? So the radius would be this one, right? Remember the concept of radius. Radius is anything that moves from the center of the circle to the circumference. Okay, so this length is going to be called 18, right? So it's 1 over 3 times pi times 18 square times height. Now what's the height? Height is 28, right? So now we're going to solve this equation and get the answer for our volume, right? So it's going to be pi times 18 square times 28, right? So we get a volume of around 9500, 9500, right? So that's 9500 cubic centimeter. So that's the volume. I hope you guys understand this and there's no more queries with regard to pyramids, the volume of the pyramids, right? Now let's move on to the last concept of the shape. Okay, so we get a lot of questions like custom built shapes of prisms. Okay, so we have spheres as well. We're going to complete spheres as well, so don't worry about it, but let's move on to this topic, which is about prisms. Okay, so can any one of you tell me what a prism is? Okay, so prism is essentially a block, a whole block of the base, right? So let's say that this is a triangle based prism. So the base of this is a triangle, right? This is a triangle, and it has three rectangular faces, one over to this side, one to this side, right? And one on the bottom, right? And it's going to be the same over here. So rectangle on this side, right? And now because it has four sides, so it has four rectangles associated with it, one on this side, one on the top, one on the bottom, one on the left side of it as well. Now if you have a hexagon base, right? So hexagon has six sides, so no matter how many sides, uh, if the sides are one, two, or three, so whatever the number of the sides are of the base is the exact same number of the rectangles that are going to be there. Okay, so I hope this is very clear. This is very clear. Okay, now um as you can see that this is a triangle, right? Triangle has three sides, so it's going to be, there's going to be three rectangles. associated with it. Now to find out the volume of the shape is going to be pretty same. Okay, so what we need to do, we need to find out the base area. Okay, and then multiply it with the height. Okay, so what's the base area for a rectangle? So for rectangular base, for a triangular base prism, we need to find out the base area of the triangle, right? And then multiply it with the height. So height is going to be this dimension of a of the shape, right? Of the rectangle. This dimension of the rectangle is going to be the height. Okay, now when it comes to rectangle base prism, it's going to be exactly the same. We're going to find out the base area. Now we're going to find out the base area of this shape, and then we're going to find out the height of this prism. Okay, which is going to be the length of the shape. So similarly with the case of hexagon as well. So we're going to find out a way to find the area of this hexagon base and then multiply it with the rectangular height. So I hope this is clear. Now I have a question right here. So let's just do this together. Okay. Now, if I have a triangular based base, right, and I have a prism, okay. So first I need to do is I need to find the height, find the base area of this shape. Okay, so how do I find the base area of this triangle? Right, it's a triangle. So the area for the base area of the triangle is what? Base area is going to be half into base into height. Okay, now what's the base? Okay, so this is the base of the triangle. We're talking about the triangle right now. So the base is 9, right? So half times 9 times height. So what's the height? Height, when I say height over here, so it's the height of the triangle, right? So height of the triangle is going to be this, and this is 4. Okay, so 4. Now 2 ones are 2, 2 twos are 4. Now it becomes 18, right? So this is going to be the base area. Now let's put it into the formula for our volume. Okay, so the volume is base area times height. Now this height is going to be the height of the whole 3D figure. Okay, so what's the base area? Base area is 18 that we've just calculated. Now the height of this whole figure is going to be what? It's going to be 12, because 12 forms 90 degree the base of the shape. Okay, so it's going to be 18 times 12, right? So 18 times 12 is going to be 216, right? So it's going to be 216. So that is the volume of the shape. So I hope that this is clear. This prism is clear to all of you as well. Is there anyone who does not understand prism? Yeah. Now there are two more figures left. Okay, so they are called spheres and hemispheres. So what's the difference between the two? Okay, so sphere is like a okay, so sphere is a ball. Okay, so it's a circular ball, right? And now hemisphere is the half of that circular ball. Okay, so this is going to be hemisphere, and this is the full sphere. Okay, so to find out the volume of a sphere, the volume of a sphere is 4 over 3 pi r cube. Now volume of the hemisphere is going to be half of that. Okay, so it's going to become 2 over 3 pi r cube. So that is the volumes of a sphere and hemisphere. Okay, so now we're gonna complete we have completed the volumes for the 3D figures. Now we've not done a lot about the total surface area because we are almost towards the end of this class. Okay, so we're gonna complete them in the next class. Okay, but is there anything that you guys did not understand with regard to this lecture? Kindly feel free to ask me. Alright, is there anyone who does not understand anything with regard to this lecture? Yeah, anything, absolutely anything that I've been taught to you. We've done a couple of questions in the beginning regarding the 2D shapes, right? And then we went on to learning about 3D figures. We've done almost every 3D figure that is in our syllabus, right? We've not done the total surface area yet, which we're gonna complete in the next class. But on the next class, we're gonna start off with some questions of the past papers regarding the 3D volume of the 3D shapes, and then we're gonna move on to the concept of total surface area, right? So, is there anyone who does not understand this? Anything? Kindly feel free to ask me. Okay, so just quickly copy of the formulas, right? I'm gonna go through the formulas again. So you're gonna have to, if you want, you can take a screenshot of this from the screen. Okay, so this one is for the cube. That's the volume of the cube. That's the total surface area of the cube, right? Now, talking about the total surface area of the cuboid. So this is the area. This is the volume of the cuboid. Then this is the total surface area of the cuboid. Now let's move on to these pyramids. Okay, so now we have square base pyramid, rectangle base pyramid. So this is the basic volume formula for the volume of the pyramids, right? And then we did some working, right? So this formula right here is for the cone. Okay, so 1 over 3 pi r square h, right? And now this is for the prism as well, base area times height. Now moving down, we have one for sphere, which is 4 over 3 pi r cube, and for hemisphere as well, which is 2 over 3 pi r cube. Okay, so I hope that you all understand this. Is there anyone who does not understand this? Kindly let me know. Perfect. So we'll hopefully see you all tomorrow on Wednesday, right? With another session. All right. Take care.